Okay, guys, so thanks very much for attending today. So I'm taking like maybe a slightly different route on this. This is mainly a talk around the potential uses and misuses of automation to potentially find security vulnerabilities. I guess like just to quickly introduce myself, my name is Marcus Pinto. I run a company called MDSec. Who you probably know, if you know of us at all, that is, as people who do a lot of training will get very excited about training and knowledge transfer. So we wrote a book called the Web Application Hacker's Handbook. And really what we've been trying to do all this time is to try and erode some of the security roadblocks that I'm sure we'll be hearing a lot about all the way through today. But maybe erode them mainly through knowledge sharing. So having done a lot of thinking, really, the only way I can think of to get rid of these roadblocks is to give the information to the people who are basically creating all these things in the first place. With that, obviously, hope that they make fewer mistakes and find vulnerabilities faster. So I prefer to think of it as embedding security expertise rather than embedding security experts, because otherwise it's not a very scalable solution, as we know. So one of the biggest things that we tend to find is when we talk to people who maybe come more from a development philosophy rather than, say, attack or hacking, generally the biggest thing they say is, I just don't think like that. So I think that's fair enough. I think I'm probably guilty in the other direction. I probably think overly too much about like, hacking things and attack side of things. So really this is also a chance to kind of meld some of those confirmation biases. Okay, so if you're not familiar with confirmation bias, really, it's just the fact that we always tend to look for things that we believe to be true. So we want to believe that the things we're believing already are actually the case. Okay, so I guess hands up quickly if you're already automating to find security issues. Okay, not too many. I thought it would be nearly everyone, but okay, fair enough. So maybe some of these things look familiar. So we've got these various Gartner sort of given terms like static assessment, which generally refers to white box analysis, so code review type tools. We've got the more black box kind of dynamic tools. We've even got ones that interactively look at an application while it's running. And then on the more kind of conventional infrastructure side, maybe you're familiar with tools like Nessus and Qualys and so on. So you can often use those just to sort of throw against your servers over the network, and they'll try to make loads of connections to different services, potentially tell you all these sorts of vulnerabilities. And if you didn't think that was enough, maybe you can give them credentials to your server, and they can log on, and they can find even more problems. I guess the question is, for the people who put up their hands, is it working? Okay, how many people are going to put up their hands saying it's working? Nobody is going to put up their hands to say it's working. Okay, right. So I guess this is a good conference to start off in then. Okay, so I think that is fair enough. I think otherwise you might have guessed I'd probably ask you a few searching questions. But if you did have a very, very expensive tool, let's say you've gone to one of these vendors and they're promised to solve world hunger by buying this tool, do you think you could think of a vulnerability that they're going to miss, a type of vulnerability? Okay, so what type of vulnerability could you potentially find?
Yeah, anything which is related to human failure, like being unconscious about certain API tokens, I shouldn't commit to source code, or I should not share with other people, stuff like this.
Okay, yeah, so maybe a token that wouldn't be recognizable as a token, yeah, or not as a security significant token.
Pretending to be somewhere else and asking me for credentials or whatever.
Okay, any others? Business logic flaws, okay. So I'd say like pretty much everyone in the room could think of something. Not only that, like I think pretty much any person that we know, not this enlightened group, but pretty much any person, if they saw something like that, they'd know that something was up and there was potentially a problem with this, this application. So clearly we shouldn't be able to execute this kind of stuff. Potentially like something bad might be happening. Okay, but if you think about those very expensive tools, they don't really understand applications. As you say, they don't understand business logic. They don't really know what your application is. Your application is just a series of buttons and forms that they need to click on and submit. They don't really know what the difference between, say, an eBay type application is from like, a Facebook or your online bank or anything else. Okay, we probably want to check up on our automation just to make sure it's doing a reasonable job. Basically, like, you've probably got some of these things which are maybe being automated. We've got black box scanning tools, which are these sort of, DAST tools I was talking about. We've got some ability to maybe run automated tools to find bugs in code. But what we really want to know is, like, are they actually working? And more to the point, since we know they're probably not working, how are we going to check up on them? Like, what checks are we going to have to make sure? If we just rely on the information coming out of the tool itself, that's obviously not very useful. So we do have ways of doing this. I think it was briefly mentioned in the last talk. We now have these things like bug bounties and particularly like red teaming for infrastructures. So red teaming was obviously born out of the fact that people kind of know that that their infrastructure scanning tools, even though they're finding all these bugs, they're not actually finding the bugs that necessarily matter. As somebody said, like false positives as a service, really a lot of these tools are. So what we really want to know is, like, how would a real hacker potentially attack us? And real hackers don't exploit the sort of vulnerabilities in the way that they're presented in these automated tools. Real attackers follow hunches, they chain together different facts, they follow trust relationships. They're very, very different beasts to people who, they don't start off running Nessus and go, right, I'm going to do that, and I'm probably going to try that. If that doesn't work, then that one. Okay, so also with the application side of things, again, we have maybe a slightly different way of thinking that comes out of people who are having a go at bug bounties. And bug bounties, in a way, are an admission that we won't get everything right. We need to have some sort of check and balance, even beyond everything else we might have. If you were to round up maybe all the vulnerabilities you could think of and put them into two categories, you maybe would come up with these kinds of categories. Okay, so there may be other ways of splitting them, but I think this is one of the most helpful. Okay, so we could think of design flaws. Things you mentioned, like some tokens that could be used to completely compromise the infrastructure, some encryption keys sitting right next to the data it's supposed to be protecting, some critical step of a workflow you could just skip over, like paying for stuff. Any of those kinds of issues are very much rooted in more kind of application design, rather than like any sort of coding or technology related issue. So on the other side, obviously, you have maybe the old favorites that you probably see trotted out all over the internet. So things like SQL injection, cross-site scripting, so on and so forth. Okay, so those are maybe more kind of like code-based flaws. And it's been our experience, possibly some other people's experience as well, but we tend to find that the split is about 55% of the vulnerabilities tend to be design flaws, and about 60% tend to be code flaws. Okay, so that was part of confirmation bias number one. So yes, you are allowed to have over 100% in that. So obviously some fall into both categories. Okay, so the real problem then is, like, some of these are going to be potentially very easy to automate and find bugs for, without too much configuration. Some of these are going to be very hard, and obviously no prizes for guessing which category we're struggling with. Okay, so what we did, like MDSec have, I think we've got about 400 different lab exercises online. And what we did is, before the vendors got any chance to see our lab exercises, we basically got hold of all the eval versions of the automated tools out there and ran them against our demo labs. And obviously then took a breakdown to see how many found what bugs. And some of these numbers need a bit of explaining, so it looks worse than it is. So when we say they found 43% of the cross-site scripting bugs, what that means is some of the cross-site scripting bugs were actually very hard to find. So they maybe found a large number of the easy-to-find bugs. So it's still like maybe a slightly better story than it might look. But some of those numbers are maybe sort of worryingly low. I guess the very low ones there, some of them are just 0%. And again, maybe that's not too surprising. So these tools didn't have a chance to configure themselves to find our bugs, but they didn't know what the access rules were, so how can they find an access control bug? Okay, so yeah, probably my favorite quote. I'm not sure I'm allowed to name him, but yeah, I quite like that one. So if we're going to look at automation, then we need to decide what types of flaws there are and how we're going to sort of remedy those, or at least either find them or not make them. Okay, so for design flaws, we probably need a lot of custom checks because the tools need to be application aware. They need to understand our specifics in order to even know what the rules are. With code flaws, we have a much easier problem, really. There could be very standard syntax, just to say, we understand that if you send this malformed string at the server and you get back any one of these, like piece of syntax, something's gone wrong. Okay, so the other problem then, these are often written by, the supposedly brilliant independent experts. They spend all their time doing this, so at least you hope that these are the experts and they're really giving you everything they can. Maybe the problem with a custom check, certainly from my experience, is that they tend to be written by those in charge of writing the flaws. Okay, so I don't know if that's everyone else's experience, but obviously you can have things like unit testing. You can have custom tests within an environment. I think if you've seen Stephen DeFries's talk on BDD security, so that was done last year. I think he does it sort of every few years. He comes out of hiding and delivers it, but it's a very good talk. It kind of helps solve these kinds of problems, like the custom design flaws. But by and large, a lot of the problems are that the people who need to write the checks are also writing the flaws, or the sorts of people. So that's the problem that I'd really like to sort of try and help solve. Okay, so quick disclaimer on automation. So I think everyone's going to say the same thing, but I think I'm talking about today's automation and today's solutions. So maybe tomorrow's will be vastly different. I fully expect my job to be automated pretty much entirely in sort of 10 to 15 years' time. I think the current tools have limited coverage, and they're actually very, very simple tools. Even though they purport to solve world hunger, they're often just looking for a single bit of syntax, or maybe a bank of syntaxes. They're just often just operating on regexes. So if you don't believe me, have a run through, fire them up against some code, see what they come back with. It's not a flaw in the tools themselves. It's just a limitation of where we are in terms of automation. But I'm sure that will change. I'm stressing not just for this audience, but also the future AI who's going to be obviously watching this televised thing. I was very much on your side, and I definitely agreed that you would exist. Okay, so back to the confirmation bias problem then. So if we could solve confirmation bias, maybe we could solve a lot of these design flaws, which are basically being checked up on by the people writing the, writing the flaws. So the problem obviously is that if you want something to be secure, then you'll tend to look for evidence that it is secure. That's human nature, and obviously the converse is also true. So maybe if you think about these sorts of people, maybe they started off with some different expectations about how things would work. If you recognize that last one, obviously, that's the very obvious sort of case of obscurity, potentially looking like a good thing up until the point it wasn't. And suddenly, people like me just start doing things like this and printing out TSA keys. And good luck patching all your suitcases, because there's probably a lot of them out there now. So really, those sorts of problems can't be solved by rigorous testing after you've already created the problem. Okay, so what I want to do just for the rest of the time really is just run through some of the interesting bugs that I think potentially show maybe some of the critical thinking and some of the ingeniousness, which hopefully you can take on to potentially challenge applications before they've even been written. So I wouldn't say before the first line of code has been written, but even when the idea has been sort of created. So the guy came up with the idea of creating some keys that works on all suitcases. That was the time to talk to him and say, by the way, you know what's going to happen, don't you? Okay, so you'll probably think that most of this actually looks quite easy, and that's actually kind of the point of the talk as well. So my parents once asked me to explain what I did as a living. I'm sure your parents have done the same. And I thought, well, okay, I'll explain SQL injection because that's easy. So I explained SQL injection. My mum looked at me and said, is that all you do? That's really easy. And I thought, well, yeah, it is. It is. So let's admit it. It is very easy. Some of these things, particularly after they're described, actually are. So let's all find these bugs because they're not sort of mystical things, rabbit out the hat type stuff. Okay, so a quick sort of idea of this sort of thinking. So let's say you're trying to break into a hotel room. How would you go about it? So some ideas. So you want to break into someone's hotel room. You lost your key card, so try and get another key. Presumably, where would you get another key from?
Maybe I would go to help desk, but this would only work for a big hotel.
Okay. Any other ideas? Is there one on the table? Well, don't know. I think that's just an ashtray, to be honest. Could be, though. Could have a look around, see if there's some lying around.
Clone an existing key workout system.
Clone a key. Room cleaners. Okay. Any others? Let's go for back here. Mug the person in the room. Okay, fair enough. Kill him. Okay. I'm going to stop now. No more suggestions. I'm on camera. Go on.
Yeah, depending on the severity, you can also bribe someone if you have.
Yeah. Okay. Bribery. Yeah. Again. Yeah. Go on. Yeah. At the back, I think another one. Sorry. Trigger fire alarm. Okay, yeah. So it's interesting though, like see how many different ideas there are, and the longer you think about it, you start to have to get a little bit creative, don't you? Possibly destructive in some cases, like mugging or killing or so on. But yeah, I mean, like most people come up with the same initial ones, like get a key printed by the receptionist. Nice piece of confirmation bias there. I had a picture of reception, so you're always going to say that. Wait for the room to be cleaned, yeah, so we can think about other things that happen in the room. A hammer, or killing or mugging, if that's more appropriate for you. So all of those are potential ways of getting into the room. But the nice way, it would be nice if we had a way of just sort of finding all these problems by brainstorming, and we didn't have to invite a room full of 200 people every time we wanted to, try and find a way in. So what we need to do really is try to think about some different ways, maybe initially by brainstorming. So we maybe come up with getting access to the machine the receptionist used to print keys. So obviously the receptionist is using a machine, hence the machine is also has a value. We could also pretend to be the guest when the room is being cleaned. We could also pretend to be the cleaner and try and get in. So maybe there's two different ways involving that. So two different types of spoofing. And there's so many different ways now, but we need to know, like, how are we going to make sure we've got them all? So it turns out you could try and think about, maybe from different points of view, you could think about different assets which might be valuable. So maybe we actually want suitcase contents rather than the room access itself. So we could think about how that asset moves around. We could think about types of people, and of course, if we think about types of people, we might come up with new methods of getting into the room. So if we think about, say, cleaner's guest concierge, concierge is a new type of person. Like, how do they operate in hotels? They probably have some sort of master key. They've got some sort of trust relationship that allows them into rooms. And then you can think of activities. So cleaners clean rooms, receptionists do stuff like issue and print keys and so on. And concierge can investigate room problems when the guests are out. And just by stating that, we know there's a problem, or there's a potential threat, because concierge clearly have a way of getting into a room when the guests are out, in this particular example. Okay, so you might have seen these sorts of things before. Microsoft refers to stride and dread as ways of potentially thinking about potential problems. Once you think you've understood enough about how the hotel works and all the operations, you can now start to think about the different threats that might occur. So I might try and spoof something, I might try and tamper with something, I might elevate my privilege somehow, get behind the desk and so on. So there's various different ways of potentially getting in. Okay. So in summary, brief summary anyway, so we can create and find problems that tools can't find. Basically, threat modeling works on hotels as well as it works on web apps. So it will outlive technology. So this is something that would work in sort of 10 years' time, 20 years' time, with technologies we haven't invented yet. So just wanted to run through some quick high-profile hacks, and there won't be much time, so you can read up about these later. But maybe you could guess some of the bugs here. Okay, so this was Apple and AT&T, so you might know these sorts of situations, but AT&T allowed access to pre-registered devices. They gave out pre-registered devices. You got a pre-registered device, and you were able to come on as a celebrity and start getting enthusiastic about the device and blogging about it. The way it worked, the web service read in an ICC-ID, which was issued sequentially to customers, and it was restricted to iPads via a user agent header. So pretty obvious bug there, hopefully. Two obvious bugs. So anyone can pretend to be an iPad just by changing their user agent, and obviously pretty much anyone can spoof the ICC-ID, particularly if they know one of them. Okay, so I'll skip through a couple of these just to get to some other interesting ones. I think this is a nice one because this is a guy who hacked something by accident. So he was trying to get to unfiltered access to the internet, so the holy grail for all techies. And he basically went through an SSH tunnel and fired up a squid proxy. And when he went to Stack Overflow, he got all the admin menus. The reason he got the admin menus, so I don't know if it's immediately obvious, but he's going through a Squid proxy. Now, Squid proxy adds an x-forwarded-for header to say who it's coming from, and it's an x-forwarded-for localhost. So when Stack Overflow got the request, it got like, oh, this is a local guy, show the local interface, because that's what we do. So yeah, you can read more about it under there. So if he's hacking that by accident, how many people are doing it on purpose and keeping a bit quiet about it? So maybe finally, like quite a nice bug against PayPal, basically a series of bugs. So each one might look like a medium low-risk bug that you might throw on the pile and say, well, we'll deal with that in the backlog. But if you put them all together, it's basically a massively serious bug. So what this guy realized was that in PayPal Manager, you could basically issue a password reset, and you were given a token that was used to identify your reset process. And if you took that token but didn't complete your own reset, and you switched context to somebody else's, then the context became associated with their account, and then your token became valid for them. Okay, so once he got that sorted out, and he got the process associated with them, he found that he could get past the account recovery question, and then he had to get the password reset working. So he tried to get password reset working initially, and he realized that if you take out the strike-throughs in the wrong place, you took out the referrer header, and you took out the cookie header, then it failed open, and it basically, again, relied on this, this token key again, which was his token key that he had from the previous, from his own reset. So he was able to reset somebody else's password by causing this sort of fail open condition. One final problem, as you're probably aware when you're using things like PayPal and so on, if you try and log on from a new address, it comes up and says, I don't know who you are, like I'm not going to let you on unless I recognize you. And of course, like the way to get around that maybe looks familiar. So he went for x-forwarded-for localhost, and that turned up to be a whitelisted address. So thought, well, you're allowed to do resets from the local host. Okay. Okay, so there have been like various other bugs, again, like in high-profile targets like GitHub. So if you know this guy, Homokov has found a few bugs against GitHub. So basically, it's a vulnerability in MVC. Basically, in summary, it's a vulnerability in the fact that there's a way of creating users, which is done by admins, a way of operating on things as an admin, and normal users actually call into the same bit of code. But if a normal user can guess the right parameters, then those parameters will be used if they exist on the admin functionality. Sorry, I'm running a little bit out of time, but this is basically all he had to do. He had to add like a parameter called public key user ID equals, and then he picked the Rails user, and he got his public key associated with the Rails user. Okay, so again, like pretty easy, potentially easy, high-profile hack, not too difficult to guess, hopefully. He found out the user ID pretty easily. Again, you can read up more about it there. Okay, so I'm going to just skip ahead because I'd prefer to take questions probably rather than going through too much more. Firstly, like hopefully these flaws don't seem too hard to understand. Okay, so you know, they're very, very trivial once I've talked about it. We didn't need to reach for a computer in order to find these bugs. I just sort of stood up here, explained what it was like, what the premise was, and almost instantly you probably started smiling and went, I know what the problem is. So a description of the environment was enough to realize what the bug was. So it's more about thinking than it is about automating. Okay, so I have to call a halt there. So what I'd just like to say, these automated tools, people talk about low-hanging fruit. Please don't use the term low-hanging fruit. Join me and use the term like low-hanging pears, okay? Because they don't find low-hanging apples. There's a lot of low-hanging apples out there. If you use automated tools, your security baseline doesn't go from there to there. It gets better, but there are still easy bugs out there. They're just not findable by the tools. Okay, so probably a good time to take questions then, if I'm allowed. Any time for questions? Yeah, if there are any. Okay, yeah.
What do you think about using tools as a regression, to avoid regression?
Absolutely, yeah. So, yes. So if you own an application, you've invested the time to configure the tools to look for all the bugs that you know about and so on, then regression is probably a really good use case. So things like BDD security and like some of these other tools that more custom written. Yes, absolutely. because you know exactly what you're looking for when you're looking for a regression. So it makes perfect sense. Whiteboards, people's phones of the whiteboard. I don't know the answer. What are you trying to do? Just store them for posterity, update them, share them? I don't know. Actually don't know the answer. I don't know if anyone else here might know the answer. Like, I think the threat models that I've seen being produced tend to be like whiteboard diagrams, and then like sort of everyone screenshots them, some comments come out, and you get some sort of document. But I haven't seen a nice kind of living document type thing that's oh, maybe Irius Risk. I haven't seen it yet, but yeah, I think the guy's downstairs talking about it. So I think there is a sort of living document form there.
So actually, quick one on that moment. I'm actually using timeframe now and dot language, and we store that in GitHub or in Git. So that's the way we're scaling, and we're creating threat models by layers. So the question for you was, how do we communicate these issues with developers, right? So do we, my view is we write tests to communicate with them so that they can replicate this.
Yeah. So I think my approach, which isn't necessarily the only one, is to give awareness sessions a bit like this, maybe over a longer period, come in and do like training courses and capture the flags and stuff, and get the thinking there. Because I think like you can't necessarily write down everything in a documented way. I think I feel it's more about the thinking really, rather than the information. I think people are drowning in information sometimes. Like you've got the ASVS, which has all the information you need, but people don't use it because it's too much for them to use, in my experience. But I don't know, how do you do it?
I try to write tests. I try to communicate with tests, integration tests, and because the story of what you just described should be in the test.
It should be. Once you know about it, it should definitely be a test, yeah. So it's more the ones that, my concern is the ones that people don't know about, the people who haven't invested the time. Like maybe if you're internal to a company and you've got the time invested to create these things on your own apps, you're a lot better state than a lot of people who just buy a tool expecting to make use of it and hope that it finds stuff. But yeah. Okay, all right. Well, thanks very much.